Let's take a look at measuring angles in radians as well as looking at arc length. I'm sure you feel pretty good about measuring angles in degrees, but probably less so in measuring them in radians. In geometry, you were given this definition of what an angle is, and that is two rays that share a common endpoint. In this case, here is our common endpoint, and our two rays extend from that. In an angle, these two rays have a special name. They're called sides. And in trigonometry, we want to think about that these two rays do share that common endpoint, but that one side is rotated away from the other side. Right? That will allow us to identify one side as being the initial side, meaning where the angle starts, and the other side being what we call the terminal side, so where the angle ends. Now, like I said, you probably feel good about measuring angles in degrees and estimating them in degrees and doing all sorts of things with angles in degrees. But we want to do them in terms of radians. So a radian is defined as an angle measure in which the radius is equal to the length of the intercepted arc. So what do we mean by that? Well, we know what the radius is, that if I look at this circle, right, this length is what we would call the radius. If we have an angle measure here, theta, that it measures 1 radian, then the arc, or the edge of the circle, this portion of it, is also going to have a length that is the same. In all 6 of these circles, I've measured an angle with a measure of 1 radian. And we want to find the missing lengths. Well, if the radius is 1, then that arc length is going to be 1 as well, because when it comes to an angle of 1 radian, the radius is equal to that arc length. Right? And so no matter how big it is, if the radius is 11, then that arc length is going to be 11 as well. And it works in both directions too, that if I know that the arc length is 1 with an angle measure of 1 radian, then the radius has to be 1. If that arc length is 5, then the radius is 5. And if that arc length is 23, then the radius is 23. So what about finding angle measures? Well, if I know that the radius and the arc length are the same, that would mean that theta has to be 1 radian. Notice that a radian doesn't get any special notation. If it were a degree, we would put a small circle up there. However, it's not a degree, so we don't put that degree symbol up there. We don't put any other identifying marks either. So when you see an angle measure with just a number, you'll know that that is a radian. But what about when I have an arc length that is twice as big as the radius? What is that angle measure going to be? Well, we know that if we cut that in half, so that we would have 1 unit over here and 1 unit over here, then this central angle would be 1 radian. And so would this one. So altogether, this would be 2 radians. In the last example here, what do you think that angle measure would be? And it's going to be that length divided by the radius. So to put all those ideas together, if I start with a radius of 1, and I know that I have an angle measure of 1 radian, then this arc length would be 1. And if I were to extend that out so that now we're dealing with 2 radians, the arc length here would be 2. But what if my radius is now 4? And we still have that same angle measure of 2 radians. How long would that arc be? Well, it would have to be twice as big as this radius, because 1 radian out here would give me an arc length of 4, and then this other radian would give me an arc length of 4. So altogether that would give me an arc length of 8. And if we went with, I don't know, like 3.5, let's say we have an arc or an angle measure of 3.5, we can be pretty safe to assume that this arc length would be that radius 4 times the 3.5, which would be 14. So let's generalize. Let's say we know what the radius is, and we know this angle measure. if that angle measure is measured in radians, to find the arc length, all we have to do is take the radius times that angle measure. So arc length is radius times angle measure. One important thing, of course, is that that angle measure has to be in radians. So a lot of times I'll refer to arc length as being radius times radians. So how many radians are in a circle? By that, I mean, if I were to ask you how many degrees were in a circle, you would say there are 360 degrees in a circle, meaning that if you measured an angle with an initial side right here and the terminal side spun all the way around for one complete revolution, that would be one circle. And we would call that 360 degrees. Right? But what about in radians? Well, let's consider a circle with a radius of 1. The arc length all the way around this circle would be whatever the circumference is. And remember that arc length is radius times radians. Well, we know that in a circle that the circumference is 2 pi r. And since r pi is 1, that means the circumference is 2 pi. In this case, our radius is 1, and we want to find out what theta is, being this angle. Dividing both sides by 1, it's obvious that theta is 2 pi, which means 360 degrees is 2 pi radians. We can come up with a nice conversion for that, just simplifying a little bit, that if I divided both sides of that by 2, we see that pi radians is equal to 180 degrees. That's a very helpful fact when we want to convert between radians and degrees. See, when we want to change units like we did in pre-algebra, changing from feet to yards or from cups to gallons or anything like that, we would take our initial measurement and write it as a fraction. Then we'd multiply by a unit multiplier, where the numerator and the denominator have the same equivalent measurement, but measured in different units. We're going to do that same thing here. And since I know that pi radians is equal to 180 degrees, I want to put the 180 degrees in the denominator and the pi radians in the numerator. The reason for that is unit-wise, the degrees are going to cancel with each other. Then we're left with a value that we just need to simplify. And we can simplify this fraction a little bit more. We see that 30 goes into 180 6 times. So this will simplify to pi over 6 radians. If we have 45 degrees, put it over 1, multiply by pi over 180 degrees, and we simplify. The degrees are going to cancel. 5 goes in there 9 times. 5 goes in there 36 times. 9 goes into there 4 times. So this will all simplify to pi over 4. With 60 degrees, we're going to multiply by pi over 180. Our degrees will cancel. 60 goes in there 3 times. So this will simplify to pi over 3. So we've looked at 30, at 45, at 60, another very important angle, 90. We should probably take a look at that one as well. So we'll have 90 over 1 times pi over 180 degrees. 90 goes into 180 twice. So this will simplify to pi over 2 radians. Let's do one more. Multiplying by pi over 180. Right. Divide both of them by 10, so we'll have 12 pi over 18. 6 goes into both of them, twice here and 3 times here. So 120 degrees is 2 pi over 3 radians. If we were going to convert the other way, one way we can do this is looking at this as being a fraction. 5 times pi over 2. And if you remember, pi over 2 was 90 degrees. So this will simplify to 450 degrees. However, if you don't remember those special radian measures, we can do the same thing where we multiply by a fraction. Of course, when we have that pi radians is 180 degrees, we want some units to cancel. Since I have pi's in the numerator, pi isn't a unit, but this is in radians, so I would want the pi radians in the denominator and the 180 degrees in the denominator. Then we would get our radians to cancel as well as those pi's, and 2/3 of 180 is 120 degrees. For 7 pi over 6, we have pi in the numerator, so it reminds us to put pi in the denominator. We'll have the 180 degrees in the numerator as well. Pi's cancel. 6 goes into 180 30 times. So 7 times 30 is 210 degrees. One last one, we're going to multiply by 180 over pi. The pi's cancel. 10 goes into 180 18 times. And -5 times -18 is -90. So it is possible for us to have a negative angle measure. Alright, so earlier this year, I took my grandson, Xander, with me. We went to go see the monster trucks. He was super excited. He loved watching them flip in the air and, brake and drive fast and be loud and everything. But the thing about monster trucks is they're huge. They have tires with a radius of 33 inches, which means our radius is going to be 33 inches if we looked at this tire as a circle. We want to see how far the truck travels after 3/4 of one tire revolution, which means as this tire starts to rotate around, the edge of the tire would come in contact with this much of the ground. And as we continue, then we continue with more contact with the ground. The tire rotates, bringing the truck along with it. So as we make it all the way to those 3/4 of the way around a circle, it would end up laying down this much tire track on the ground, basically moving the truck that far down the road. So this distance that we want is going to be the same as this arc length. Remember that arc length is radius times radians. We know that in this example, our radius is 33 inches. And our angle measure is 3/4 of a revolution. So 3/4 of one trip around the circle. And how many radians are in one trip around a circle? There are 2 pi of them. So when we simplify, we'll have 33 times 3 pi over 2. So we grab our calculator, multiply that all together. 3 times 33 is 99 times pi divided by 2, and we get about 155.5 inches, which is over 10 feet, and the tire hasn't even spun one time. So that's a lot right now. So a couple big things to remember is that in a circle, we're used to 360 degrees, but that's equal to 2 pi radians. Right? When we want to convert between degrees and radians, we're either going to multiply by pi over 180 degrees or by 180 degrees over pi. The other thing to remember is arc length. That when you want to find the length of an arc, all you have to do is take a radius times radians.